Hello and welcome to Prolific's Ansible Automation Platform webinar, where we'll be learning all about the Ansible Automation Platform as a whole, the Ansible engine, Ansible Tower, a few use cases for Ansible, and moving on to a demo where you'll be shown how to provision a server on AWS. But first of all, I'm just going to say a few words about who Prolifics are and what we do, for those of you who don't already know. So Prolifics are a global solutions provider with deep software engineering expertise and are a trusted advisor to many leading UK businesses. We help organizations excel in digital innovation. Our architects and engineers unlock the value of data through APIs and integration, cloud native development, automation, and enterprise DevOps. Our outcome-based solutions are delivered in a blended model, utilizing our onshore, nearshore, and offshore teams. These teams also provide cost-effective managed services to ensure business continuity, something we're seeing is far more prevalent in the modern day. So we've partnered with Red Hat because we see open source as the future, and Ansible at the very heart of that. So we're faced with numerous challenges in IT. You live them every day, regardless of your role or responsibility. Effort leads to time, and time equals money. But effort also has a human toll. In the end, we're just people trying to work with other people and force machines to do the work to be done. Your reasons for automating are relatively straightforward. You're tired of doing the same thing over and over again. Automation makes our jobs and lives easier and presents an opportunity to do more. Now, you'll all often perform those same tasks over and over, but as every business becomes digitally driven, technology is your innovation engine. So instead of doing those same tasks over and over, you are going to be able to do them once and automate all those solutions moving forward. So, one common thing that we see in the industry is siloed automation. Now, siloed automation leads to technical debt and delayed success by deterring communication and collaboration among teams. Like any ad hoc approach, siloed automation increases the risk of human error and lacks the responsiveness that a centralized automation approach provides. Ansible's mission is to simplify work and reduce complexity by breaking down these silos between IT teams to increase the speed of transformation and use best practices to manage automation in source control. Ansible automation is the enterprise framework for automating across IT operations. Ansible Engine runs Ansible playbooks, the automation language that can perfectly describe an IT application infrastructure. Ansible Tower allows you to scale IT automation, manage complex deployments, and increase the speed of productivity. It empowers development to production from IT to the business. So some of you may be asking, why Ansible? So let's run through a couple of the features that make Ansible so popular. First and foremost, YAML is a great choice for configuration tool because it's human readable, making it usable across teams and not requiring any special coding skills. YAML files can easily be translated into multiple language types, and it's built to be simple to use, which means less startup time to get up and running. Also, with Ansible, you can automate cross-platform. Its agentless architecture supports all major operating system variants: physical, virtual, clouds, and network. Ansible is also built for multi-tier deployment. We know that nobody deploys a single service on a single machine anymore. You're likely dealing with clustered applications, multiple data centers, public, private, and hybrid clouds and applications. Ansible models your IT infrastructure by describing how all of your systems interrelate rather than just managing one system at a time. As an orchestration tool, Ansible plays well with others. It can be integrated with Jenkins, Puppet, HPSA, etc. One of Ansible's benefits is the ability to share and reuse the created roles among other projects and applications. So what can you do using Ansible? Well, centralizing configuration, file management, and deployment is a common use case for Ansible, and it's how many users are first introduced to the automation platform. But Ansible's possible use cases go far beyond this, and it merges the best concepts from configuration management, application deployment systems, and workflow-based orchestration systems to perform provisioning, auditing, security, compliance, and much more. It can automate IT environments, whether they're hosted on traditional bare metal servers, virtualization platforms, or in the cloud, as well as the configuration of a wide range of systems, devices, database, devices, networks, and firewalls. Ansible is the only automation engine that can automate the entire application lifecycle and continuous delivery pipeline. By turning difficult tasks into simplified playbooks, you're going to see major increases in the speed of production and quality of delivery. The playbook syntax also allows you to define, secure any part of your system, whether it's setting firewall rules, locking down users and groups, or applying custom security policies. So I mentioned on an earlier slide that Ansible works against practices like automating in silos to bring teams together and boost collaboration. Now, when I talk about bringing teams together, this isn't restricted to just IT. I've also spoken to one of Ansible's primary benefits about how easy it is for non-programmers to learn and how quickly it can become productive. These features draw in new users from different domains, whether that's security or lines of business, allowing Ansible to grow within an organization into a general purpose automation solution, capable of automating a wide variety of manual tasks. All users contribute to network automation and work together to build this out, the enterprise and individual use cases. In real life, automation crosses teams, so why not have a platform that does this all as well? Now, on the screen right now is a few numbers just showing you how amazing and useful Ansible Tower is. We've seen there's a 94% reduction in recovery time following security incidents, 84% savings by deploying workloads to generic systems appliances using Ansible Tower, and 67% reduction in man hours required for customer deliveries. This all leads to a 146% return on investment for Ansible Tower, and that payback can be in less than 3 months. So from a business perspective, you can't get much better than that. Now, I'm going to go into a little bit more detail on certain areas of Ansible, starting off with Ansible Engine. So the Ansible project is one of the most popular open source projects with thousands of contributions since it was launched 8 years ago and over 500,000 downloads per month. Ansible Engine was created in response to the requests for additional Red Hat offerings for diverse automation use cases. So what is it? Ansible automation is a foundation for enterprise automation and includes the building blocks for automating and managing at scale with Red Hat Ansible Tower. Ansible Engine is also available for individuals and small teams to receive support for their Ansible environments, even when they do not need enterprise scalability via Ansible Tower. Like everything else, Ansible, the automation engine architecture is very straightforward and easy to understand. We're going to look at the 4 main components of this architecture here: the inventory, modules, command line interface, and plugins. We can take a step back for clarity and see that this diagram shows a hypothetical user who is writing the Ansible playbook to execute the Ansible orchestration while interacting with the services of private or public clouds and configuration management database. Hosts are basically the node systems in the Ansible architecture getting automated by Ansible only. They can be any type of machine, such as Windows, Red Hat, Linux, etc. Within the engine itself, inventory contains the list of nodes along with their IP addresses, databases, servers, etc., which are managed through Ansible. An inventory can also organize managed nodes, creating in nesting groups for easier scaling. When you run a playbook, It's the modules that get executed on your hosts, and these modules contain actions in them. So when you run a playbook, those actions take place on your host machines. You also have the option to create custom modules, although there are hundreds of Ansible provided modules that will automate almost every part of your environment already. These modules can reside on any machine, no databases or servers required here. Plugins here are a special kind of module, pieces of code which expand Ansible's core functionalities. These plugins get executed before a module is getting executed on the nodes. Callback plugins get executed on the main control machine for logging purposes, while cache plugins are used to hold a cache of inventory source data to avoid retrieving them from the source. Ansible also has action plugins, which are front-end modules, and they can execute tasks on the controller machine before calling the modules themselves. So on the screen here are just a few of the great features that Ansible Engine has, such as cross-platform, that's human readable, dynamic inventories, etc., etc. Moving on to section 2, which will be covering Ansible Tower. So Ansible Tower is a remarkably useful add-on to Ansible, able to do much of what can be done on the command line interface. It will complement, not replace, the main application by automating and presenting some of the main tasks graphically. It also greatly helps to reduce the intimidation factor for those new to Ansible or those inexperienced with automation by presenting basically a much easier to understand visual tool, and the one that can be presented back to lines of business. When more than one person is running the same playbook in the organization, Ansible Tower is very valuable. With things like role-based access control, you can set up teams and users in various roles. These can integrate with your existing LDAP or AD environment. These keep the environment secure and efficient. All Ansible automations are centrally logged, ensuring complete auditability and compliance. And this allows you to centralize and control your IT infrastructure with a beautiful visual dashboard, role-based access controls, job scheduling, integrated notifications, and graphical inventory management. Now shown on this slide are just a few of the fantastic features in Ansible Tower, such as the RESTful APIs, where API first mentality of every feature and function of Ansible Tower can be API driven, allowing seamless integration with other tools like ServiceNow and Infloblocks, and workflows and centralized login. The list does truly go on. So shown here is the entire Ansible automation platform at work. Now, workflows have admin and execute permissions, similar to job templates, and accomplish the task of tracking a full set of jobs that were part of the release process as a single unit. Several workflows can be launched simultaneously, and you can set them a schedule for when to launch them. You also have the ability to set notifications on workflows, such as when a job completes, which is similar to that of job templates. Job or workflow templates are linked together using a graph-like structure called nodes. These nodes can be job, product syncs, or inventory syncs. A template can be part of a different workflow or used multiple times in the same workflow. A copy of the graph structure is saved to a workflow job when you launch the workflow. Let's connect back to something I've mentioned a few times now, but just wanted to instill the point about how friendly Ansible Tower really is and how it's a collaborative tool. Only the admin role can edit or delete a job template. And to create a workflow job template, you must be an organization or system admin. But organization admins can create a blank workflow and then grant an admin role to a low-level user who can then go on about delegating more access and building a graph. So it's there and friendly for absolutely everyone. So we're now going to move on to section 3, where we'll be briefly going through some of the use cases, some of the modules that are attached, and some of the human readable code that we spoke about earlier on in the presentation. So first of all, you can use Ansible for essentially anything. whatever you're trying to do, from provisioning to configuration management, orchestration, application deployment, continuous delivery, and security and compliance. You can automate all of these with the exact same tool. So for example, Linux automation, there are over 150 Linux modules, and you can automate anything Linux. And here's some of the code showing how easy it is for anyone to understand exactly what needs to be done. Automation, there are over 100 Windows modules and 1,300 PowerShell DSC resources, meaning they work together very, very well. Again, more of the code showing just how simple it is to read. For network automation as well, another popular use case, there are 50 network platforms and over 700 network modules. Cloud automation, again, over 800 cloud modules and 30 plus cloud platforms. And on the screen right here is an example for AWS, which we're going to in a little bit more detail later on in the demo. So essentially what this does is it conducts the orchestra. Ansible sits atop all of the things on your screen right now, from Puppet to Terraform to Kubernetes, etc., and just really works well with absolutely everything. So you don't need to get rid of your current tool set. You can have Ansible sit atop and conduct it all and work with them all brilliantly. So now I'm going to move on to our demo. So I will pass over to Pat Harrison, who will take us through.
Thanks, Harry. In this demo, we're going to look at how we can use the Ansible automation platform for provisioning. And in this specific example, we're going to provision virtual machines in AWS. So I'm going to go ahead and kick off the provisioning workflow because it takes a few minutes to run. While that's running, we'll come back and talk about some of the concepts of Tower and have a look at what's happening. So the first thing that's happened here is it's brought up a dialog here as I've run this job. It's asking me how many nodes I want to provision. It's asking me the size, and it's also asking me what operating system. So do I want Red Hat Enterprise Linux or Windows? And this is a custom dialog. You can create your own. And I'm just going to quickly talk high-level overview of what this is actually going to do. So the first thing that's going to happen is we're going to provision a VPC in AWS, and actually, things like the security groups, the routing, the internet gateway, and the virtual subnets. Once that's completed, I'm going to provision my Windows instances. So again, I asked for 3 here, so I'll get 3 instances. And in parallel, while the Windows instances are provisioning, I'm also going to create an F5 load balancer. And then once the Windows instances finish provisioning, they're going to go off and I'm going to install IIS and I'm going to create a basic web server. And the F5 instance, I'm going to configure that as well. And I'm going to add all of those Windows instances into the F5 load balancer pool. So if we go ahead and look here in AWS, you can see at the moment I've only got a single instance, which is my Ansible Tower node. Hopefully if we refresh the screen now, we might see, no, not quite yet. What I'm hoping to see in a moment though is my new instances provisioning. So there's my F5 load balancer, it's just started up. So that's just going to start provisioning. And hopefully if I refresh again, we will see, there we go, there's my Windows instances starting up now. So we can see my instances provisioning. And if I just jump back into Ansible Tower here, I just want to make a note at this point that at the moment, Ansible Tower is only aware of one host. So it's only managing a single host. We aren't managing anything else. So let's have a kind of a look at some of the concepts and features of Ansible Tower and kind of where it fits into the Ansible automation platform. So if you think of Ansible being a kind of simple automation tool to install, it's a simple automation tool, language to learn. So it's very easy to get up and running with Ansible. But to take that from kind of testing and development into an automation platform that multiple teams could use, that's kind of what Ansible Tower is there to address. It's there to say, I've now got an automation platform that people can use. I can make it highly available if I want to. I can ensure that it scales to manage hundreds, thousands, or tens of thousands of endpoints. And I'm going to put in some of the controls in place that I need to run this in an enterprise environment. So, things like credential management. So all of the credentials I need to connect to my endpoints, whether they're Windows or AWS in this instance, I need those. I need access to those in a controlled way. Role-based access, so who can automate, what jobs they can run, what devices they're allowed to automate against. I can control all of that with Tower. And then things like all of the centralized auditing and logging. So I know who's been automating, what they've been doing, what jobs have been successful, what's failed. That kind of information is really what I'm after here. And that's what Tower is providing. So let's go ahead and look at Ansible Tower's credential management. So this is Tower's own credential management. This is an Ansible Vault. And I guess the key difference is that with Ansible Vault, I can obviously encrypt secrets and passwords and things like that. But if I want to hand off automation to another team, I need to also give them the key to decrypt that Ansible Vault file. And if I'm doing that, I'm basically giving them access to, if they want to, view that Vault file, retrieve those credentials, and there'd be nothing to stop them manually logging into that device potentially and making changes out of band, out of the remit and control of what the automation platform's giving them. So that key difference here with Ansible Tower is I'm storing all of my credentials here. And if we go and look at, for example, this Windows administrator account, we can see the password's encrypted. And there's no way for me to kind of decrypt that and take a look at it. I can hand this off to another user, knowing that they could use this credential within the automation platform itself, but they couldn't use it outside of that to make manual changes. And we can see here I've got, things like my AWS account in here, so I can create my instances. I've got my F5 load balancer credentials in here, and even things like ServiceNow are in here. And then finally, if you have a third-party credential vault like CyberArk, or maybe something like HashiCorp Vault, we can also reach into those from Ansible Tower. So Tower can go in there, grab the credential you give it access to, use those for the automation run, and then those third-party vaults can go and do rotation and things like that they do well, without Ansible Tower actually having to directly manage those credentials. And then the other kind of part of, another part of the Ansible platform, and really, best practices around Ansible are to treat your automation, treat your playbooks, variables like their code. So I want to make sure that they're in source control, because that provides me a whole bunch of benefits around, feature branches, being able to tag things, making sure things are peer reviewed before they get pushed into a production branch. Because I don't want people to have local copies of Ansible playbooks and variables on their own control machine, and they're all different. We're going to end up in hell there. So a project is a one-to-one mapping with a source control repository. In this instance, it's my GitLab repository. It's a private repository, so I need a GitLab credential to get to it. So again, that's all in Ansible Tower. And we can see here, we can be quite granular here with, do I want to pull from a specific branch like dev or, something else? Do I want a specific tag or commit? Again, this is all about Ansible Tower being, in that enterprise environment, I want to understand exactly what playbooks and variables I'm pulling from source control and running in production. Now, once I've defined that mapping between Ansible Tower and my source control repository with that project, I can then go ahead and sync all of the playbooks that it finds. So if we look here in this AWS project that I've got here, here are all the playbooks that we've discovered from that source control repository. And what we're defining here in a job template really is think of when you run Ansible playbook from the command line, what options are you passing into that when you run the playbook? So we've also got the name of the playbook here. Things like, am I in -- check mode, or run? The inventory that I want to map to. Just below that, the credentials that I want to use. So here's some F5 credentials, but maybe I need, additional credentials for whatever reason. I can map all of those in. Things like the limit of what I want to run this against. So, again, equivalent to the -- limit from the command line. And other flags that you'll notice here if you're used to running Ansible playbook from the command line. So kind of the -vs, tags, privilege escalation, a whole bunch of options here on how we can run this job. And of course, we could set up a schedule here as well and define, that this job runs once a week, once a month, whatever it might be. Okay, and I'm going to just go back to the Ansible Tower dashboard, because if you remember earlier, we had a single host. You can see now we've got 5 hosts. So there's some sort of discovery process that's happened here. It's not quite a discovery, but if we go and look here at my inventory in Ansible Tower, we can see here I've defined a source for this inventory. So I'm not manually adding hosts into this inventory. I'm using a source of truth. And we can see here we've got a whole different bunch of sources here. So we've got EC2, which is the one I'm using in this case. But there's also things like Azure, vCenter, Red Hat Satellite, OpenStack, and so on. What's happening here is I'm dynamically discovering hosts. So I'm going off to this source of truth, which in this case is EC2, and I'm asking it to go and retrieve a list of the hosts that it's found. So when we started this process off, I had no idea what IP addresses I would get from these instances once they were provisioned in AWS. I didn't know what internal addresses they would get. There's a whole bunch of information that I just wasn't aware of. And so I'm able to use this dynamic inventory to go and discover that information for me. So if I go and pick one of these instances it's found, we can see here that actually this is my F5 load balancer, this one. So it's got a tag name Ansible Big IP. But we can see it's also found things like its VPC ID, security group name, the region it's running in, the AMI ID, a whole bunch of additional information. And the same here for things like the Windows server. It's found additional tags. It's found out that it's a Windows box. And if I go ahead and click into this host, we can see a whole bunch of facts and variables it's discovered from that source of truth. So here for AWS, it's discovered things like the private DNS name, the private IP. So, these are all facts and variables we can use in our automation run. So we mentioned earlier that Ansible Tower provides that centralized logging and auditing of all of the jobs that are running. So we can see here all of the jobs that are run in this Tower instance. And I'm going to go and select my workflow here, the one we kicked off earlier. We can see it's all green. It says it's successful. But let's click into the details of one of these specific jobs. If we focus here on the left-hand side, we can see details like the job was successful, how long it took to run, the user that initiated it. Here it was the admin user. We can see the name of the playbook. We can actually see here the commit ID from my source control repository. So if I jump into GitHub here and look at the commits, this is the repository we're running it from. We can see here this commit of 711 ACA1. Well, that's the same commit here. So I know exactly what version of this playbook was run at this time, and all of the associated variables. I'm not guessing what was in here at the time. I know exactly what it was. And then on the right-hand side here, it's the kind of familiar Ansible playbook output we see here. So we've got the, in this case, the VPC already existed, the subnet already existed. So it's just run through these jobs. And remember, Ansible's a desired state engine. So if it doesn't need to make changes, it won't do. It will report back that everything was in the desired state and nothing's changed. So again, just going back to this workflow, we can see each of these is an individual job, individual playbook that's being run. And again, if we go and click on this web server one, we can see here that this one did actually make changes. We installed IIS on all of our web servers. And actually, we can drill into the details of those tasks as well. And here's a whole bunch of additional metadata about, what options were passed to it, what happened when it ran. So let's go ahead and look at what we actually created here in this one. So I'm going to get the IP address of my F5 load balancer. I didn't replace certificates on there, so they're self-signed. I just need to accept that warning. And so here's the kind of management console for my F5 load balancer. If I go ahead and look at for example, the pools in here, we can see I created an Ansible HTTP pool. And if I look at the members, we can see here there's 3 members that have been added here, which are the 3 Windows instances. And for example, this first one ends with an IP of 36.88. If we go into EC2 again, there it is, 36.88 is the instance here. So we can see it's added in those 3 Windows instances. And I'm just going to grab the virtual IP from this load balancer. Again, no certificates were replaced in here, but we can see here, here's the basic IIS site we created. And I'm using some of those facts that we can discover with Ansible. So the IP address and the operating system. And if we refresh here, here's our 3 instances that we're load balancing in this F5 load balancer. And then finally, a note on Ansible Tower's role-based access. So actually, what we can do in Ansible Tower is we can map to authentication providers, so Azure, LDAP, TACACS. And then we can create users and groups, so either mapped from these identity sources, or they can be local in Tower. So here I've got a local user called Windows, and I can see here that under permissions they've only got permissions to execute a single job, which is a Windows config management job. And I'm also going to give them access to, allow them to use the Windows inventory, my AWS inventory. So they can't update it or change it, but they are allowed to use it. So let's have a look what happens when we log in as that user. We can see here now, if we go to credentials, they don't have access to any credentials. We can see they don't have access to any projects. And from a job template perspective, they've only got access to 1 job. And if we go and look at this, the credentials are already mapped in there, which is why I don't need to give them access to credentials. They're already defined in the job. And we can see all of these fields are read-only, so I'm not allowing them to change anything. And so actually the only thing they can do is effectively this push button automation. They can launch this job, and this job will go off and run some kind of Windows config management, so maybe adding users and groups, or maybe installing features, or making sure services are in a specific state. So just to recap here what we've looked at then. So we've looked at how we can use Ansible to automate provisioning of instances and automate the configuration of those instances once they've been provisioned, including network devices. And we've looked at that orchestration capability where we're provisioning and then we're passing information from one platform to another. So we've got IP addresses that we passed into our F5 load balancer. And so we've ended up with new instances, an F5 load balancer and an IIS-based web service that we're serving from it. And here we are with another use case here where we're using some Windows config management and providing kind of push button automation for other users to consume. Okay, back to you, Harry.
Thank you very much, Pat. That was really good. So to finish off, I'm just going to run through a couple of the great case studies that and success stories that Red Hat had with Ansible. So first of all, Microsoft, one that you all may know. Microsoft needed to address their increasing complexity across their corporate network infrastructures. We're talking about tens of thousands of endpoints that connects Microsoft locations worldwide. Part of Microsoft's strategic mission is end-to-end digitization, building an approach that will simplify processes and experience for end users across all of its services and applications. As a key part of this shift, Microsoft used Red Hat Ansible to create a standardized, centralized automation environment that reduces the amount of routine, repeatable tasks and complexity for their teams, allowing them to focus on sharing knowledge and delivering new and innovative solutions. Using Ansible, Microsoft succeeded in advancing their automation process from manual scripting and changed to a continuous integration and delivery approach, supported by a centralized service-based architecture. They can continue scaling to support customer demands at a much faster pace and are saving thousands of hours of operational work. Companies like Microsoft can also contribute back to the open source Ansible community as they continue to develop new solutions. Another case study is NetApp. So NetApp is the data authority for hybrid cloud. They provide a range of data services to global organizations to simplify and integrate data management. They wanted the speed of their IT service delivery to be both faster and more efficient. Many IT organizations can appreciate that this is a challenging task, and NetApp was hindered by repetitive manual processes. For example, updating network time protocol. Clients of the NetApp's thousands of servers manually took about 5 minutes per machine, or 25,000 total minutes. NetApp turned to Red Hat Ansible engine to eliminate repetitive manual tasks in the configuration management. They have streamlined the iterative configuration file changes that I just mentioned, and the updating time went from weeks to days, plus eliminating the human error that comes along with doing these tasks manually. Consequently, NetApp saw application delivery go from weeks to minutes, maintaining IT infrastructure became more efficient and accurate, and the successes with Ansible became part of a wider movement towards making proactive and strategic IT initiatives. And finally, Deutsche Bank. Deutsche Bank challenged traditional business approaches. They wanted greater agility and wanted to use that agility to drive more innovation. By enhancing the developer experience, they sought to provide a better customer experience. Application development was slow, and apps just weren't getting to customers fast enough. Thousands of servers and databases hindered the growth of the adoption of more agile technology. Ansible Tower plays a key role in supporting Fabric, a containerized microservices-based application development platform. Instead of 6 to 9 months, applications now go from proof of concept to production in 2 to 3 weeks. Red Hat Ansible Tower automates provisioning, testing, and other routine tasks, saving the company months of engineering work and mitigating the risk of errors during upgrades and maintenance. The flexibility of Ansible Tower supports DevOps approaches to developing at scale and supports global application development in a democratic way, giving developers more freedom and more control. So thank you very much for listening to this webinar thus far. Now I would like to open the floor up to questions. So everyone on this webinar will be unmuted. So please do let us know if you have any questions you would like answered. Thank you very much.